Hi students, good morning, welcome to the class. So in our last class, we discussed about change of states. In change of states, solid is going to be converted into liquid, liquid is going to be converted into gas, again gas is going to be converted into what? Solid. So many things we discussed. So in there, how they are going to be converted, at what temperature, what we are going to call as the stages, right? So we called first one melting point, right? So after that one vaporization, boiling point, sublimation, right? So many terms we are discussing in our last class, right? So in our today's class we are going to discuss latent heat. Latent heat. See here the amount of heat required. The amount of heat required. Suppose if a substance is having, see here, the amount of heat required per unit mass. So then can I write here Q divided by M? So amount of heat means Q per unit mass means divided by M of the substance to change its state. To change its state at a constant temperature. Temperature constant ಇರಬೇಕು. Constant temperature ಇದ್ದುಕೊಂಡು ಏನಾಗಬೇಕು? The heat per unit mass of the substance ತಗೊಂಡು ಏನು ಚೇಂಜ್ ಆಗಬೇಕು? ಅದರ ಸ್ಟೇಟ್ ಚೇಂಜ್ ಆಗಬೇಕು. Solid to liquid, liquid to solid, right? Liquid to gas, gas to liquid. Getting my point? So then to change its state at a constant temperature is called latent heat. ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ? latent heat ಅಂತ ಹೇಳ್ತೀವಿ. We call latent heat. The amount of heat required per unit mass of the substance to change its state at a constant temperature is called what? Latent heat. Latent heat, right? If a substance, we will consider now, see, if a substance of mass m, one substance ತಗೋತೀನಿ ನಾನು, ಆ substance mass ಏನೈತಿ? m ಐತಿ, right? It undergoes a change of one state to other state. So the amount of heat required to change the state right? No. ಈಗ ನಾನು ತಗೋತೀನಿ, ನನ್ನ ಕಡೆ Q ಐತಿ. Q means what here? Amount of heat is directly proportional to what? Mass. Now see, or we can also say ಹೇಳ್ಬೋದು. Amount of heat is directly proportional to mass. Now see, here Q, I am going to remove this one, is equal to L. Is equal to what? L. This is your M, right? So then L is equal to Q divided by M. So this is amount of heat per unit mass is called as what? Latent heat. Here the constant L is called latent heat. Constant L ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ latent heat ಅಂತ ಹೇಳ್ತೀನಿ. Here L is constant and is called is called what? Latent heat. ಅದಕ್ಕೆ ನಾನು ಏನಂತ ಹೇಳ್ತೀನಿ? Latent heat ಅಂತ ಹೇಳ್ತೀನಿ. ಏನಿಲ್ಲ, ಸಿಂಪಲ್. The amount of heat per unit mass ಅಂತ ಹೇಳಿದ್ರೆ ಮುಗಿತು. It is called latent heat. Latent, correct. So then, next one, latent heat of fusion. So ಇದರೊಳಗೆ ಏನು ಬರ್ತಾವೆ? ಒಂದು latent heat of fusion ಬರ್ತೈತಿ, ಇನ್ನೊಂದು latent heat of vaporization ಬರ್ತೈತಿ. So ಒಂದೇ ನೋಡ್ರಿ, latent heat of fusion. Latent heat of fusion. Here this is denoted by capital L small f. Capital L small f. Right. So the amount of heat required per unit mass, the amount of heat, the amount of heat required per unit mass of the substance to change from solid to liquid state. Right? Fusion fusion, solid to liquid state at a constant temperature. Is called what? Latent heat of fusion. So here for water LF is latent heat of fusion is how much means? That is 3.33 into 10 raised to 5. 3.33 into 10 raised to 5. ನೋಡ್ರಿ, latent heat ಹೇಳ್ಬೋದು. heat ಅಂತ ಎಲ್ಲ ಹೇಳ್ತೀವಿ ಜೌಲ್ಸ್, ಮಾಸ್ ಅಂದ್ರೆ ಕೆಜಿ, ಮಾಸ್ ಮ್ಯಾಗ ಹೋಯ್ರಿ joules per kg. Joules per kg. ಗೊತ್ತಿದೆ. Joules per kg. Right? ಇದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ? Latent heat of fusion ಅಂತ ಹೇಳ್ತೀವಿ. Latent heat of fusion. So next one ನೋಡ್ರಿ, latent heat of vaporization. Latent heat of what? Vaporization. ನೋಡ್ರಿ. So one heading, latent heat of vaporization. Latent heat of vaporization. Right? So here once again the amount of heat required per unit mass of the substance to change from liquid to gas state at a constant constant temperature. At a constant temperature is called what? Latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. So LV is equal to, for water, once again, for water, LV is equal to, how much it is there means, it is 22.6, 22.6 into 10 raised to 5, say, joules per kg, right? Joules per kg. So this is latent heat of ಇದಕ್ಕೆ ನಾವೇನು ಅಂತೀವಿ latent heat ಅಂತ ಹೇಳ್ತೀವಿ. latent heat of fusion ಅಂತ ಬರ್ತದೆ, latent heat of vaporization ಅಂತ ಬರ್ತೈತಿ, right? Next one we are going to discuss, that is heat transfer. Heat transfer. In heat transfer. Heat transfer ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗಾಗುತ್ತೆ? At what temperature? ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಒಳಗೆ ಹೀಟ್ ಏನಾಗುತ್ತೆ? ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತೈತಿ. ಯಾವ ಸಿಸ್ಟಮ್ ಇಂದ ಒಂದು ಸಿಸ್ಟಮ್ ಇಂದ ಇನ್ನೊಂದು ಸಿಸ್ಟಮ್ ಗೆ ಹೇಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತೈತಿ, ರೈಟ್? ನಾವು ಡಿಸ್ಕಸ್ one by one, right? So here heat transfer, right? Heat transfer. Heat transfer. Right. So here transfer of heat energy. Transfer of heat energy from one system to another. One system to another, given difference temperature. Given difference temperature, right? Is called what? Heat transfer. Is called heat transfer. So one system ಲಿಂದ ಇನ್ನೊಂದು ಸಿಸ್ಟಮ್ ಗೆ ಏನಾಗಿರ್ತದ? ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಿರ್ತದ, ರೈಟ್? ಆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗೋದ್ನಾಗ ಟೆಂಪರೇಚರ್ ಎಷ್ಟೈತಿ, at what degree Celsius, at what degree Kelvin it is going to be transferring. So ಈ ಬಾಡಿ ಒಳಗೆ ಇದ್ದಂತ ಹೀಟ್ ಈ ಬಾಡಿಗೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ? ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ at what degree Celsius the what that should be going to be converted. So that is our what? Heat transfer. Right? So here in this heat transfer there are three types. Heat transfer has three types. Heat transfer ಒಳಗೆ ಎಷ್ಟು ಟೈಪ್ ಅದಾವೆ? ಮೂರು ಟೈಪ್ ಅದಾವ, ರೈಟ್? ಸೊ ಫಸ್ಟ್ ಒನ್ conduction, right? Second one convection, and third one radiation, and the third one radiation. So these are the three types of heat transfers. These are the three types of what? Heat transfer. Right. Now we are going to discuss the first one, conduction. Right. Here, first one, conduction. Here, first one, what? Conduction. Then, what is conduction? How it is going to be described? Now we are going to discuss. Right. Here, conduction, first one. Right. So, conduction is the mechanism of conduction is the mechanism of transfer of heat. Conduction is the mechanism of transfer of heat between two adjacent parts of the body. Between two adjacent parts of the body. So between two adjacent parts of the body, because of their temperature difference. Because of their temperature difference, right? So here heat is transferred between transferred between neighboring parts of molecules of the body. Right? Without any flow of matter. Without any flow of matter. Right? See, here what happens? If you are going to consider here, suppose Here what happens? The length of this rod is L. The length of this rod is L. Here, this part is I am going to take TC. This part is I am going to take TD. So TD and TC are temperature of those parts, right? So there is a length. That length is what? The L is the length of this what rod. So, or I am going to consider here. Consider a length, or consider a rod of length L. Consider a rod of length L. Consider a rod of length L with, so this is the cross section area, with cross section area, with cross section area A. So ಇದಕ್ಕೆ ನಾನು ಏನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಒಂದು ರಾಡ್ ಐತಿ, ಆ ರಾಡ್ ಲೆಂತ್ ಏನೈತಿ L ಐತಿ, ಅದರ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಏನೈತಿ ಗೊತ್ತಿರಬೇಕು, ರೈಟ್? See here there is a temperature is TC in this part. In this part there is a temperature is TD. So here this TC is greater than TD. TC is greater than what? TD. TC ಜಾಸ್ತಿ ಎದಕ್ಕಿಂತ TD ಕಿಂತ. So then here in this part the temperature is, here in this part the temperature is what happens? More than this part. More than this part. Now can I say this part is hot, this part is what? Cold. ಈ part ಏನೈತ್ರಿ? Hot ಐತ್ರಿ, ಈ part ಏನೈತ್ರಿ? Cold ಐತ್ರಿ, ಇದು cold ಐತ್ರಿ, right? So then here what happens? The rate of flow of heat, the rate of flow of heat. See, the rate of flow of heat. ಏನಂತ ಹೇಳ್ಬೋದು? The rate of flow of heat ಅಂತ ನಾವೇನಂತ ಹೇಳ್ಬೋದು? Here see, Q by T. Q by T, the rate of flow of heat. ಯಾವಾಗಲೂ ರೇಟ್ ಅಂತ ತಗೊಂಡ್ರೆ by T ಮಾಡಬೇಕು ನಾವು. by ಏನು ಮಾಡಬೇಕು? T ಮಾಡಬೇಕು, ಗೊತ್ತಿರಬೇಕು. So the rate of flow of heat is directly proportional to the area. It is my point, right? ಅಥವಾ ನಾನು ಹೀಗೆ ಬರೀತೀನಿ ಬಂದಲ್ಲಿ. So first one, rate of flow of heat is directly proportional to area, right? So then can I get Q by T is directly proportional to area? Is directly proportional to area? So then see here what happens? Very important. So the heat is transferred from here to here. ಯಾಕಂದ್ರೆ adjacent body ಅಂತ ಹೇಳಿದ್ರೆ ಏನಂದ್ರೆ ನಾವು conduction is the mechanism of the transfer of heat between the two adjacent parts. ಇದೊಂದು adjacent part, ಇದೊಂದು adjacent part. ಇಲ್ಲಿ heat ಹೆಚ್ಚೈತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕಡಿಮೆ ಐತೆ ಅಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ಏನಾಗ್ತೈತಿ? ಬಾಡಿ ಫ್ಲೋ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತೈತಿ, heat flow ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತೈತಿ. So there temperature difference. ಇಲ್ಲಿ temperature ಹೆಚ್ಚೈತಿ, ಕಡಿಮೆ ಐತಿ. So then the difference is there. Getting my point? So then the transfer between neighboring parts of the molecule, one molecule heat ತಗೊಂಡು ಈ molecule ಕಡೆ ಏನಾಗ್ತಾವ? Flow ಆಗ್ತಾ ಹೋಗ್ತಾವ, right? So then what happens here? The rate of flow of heat is once again directly proportional to the temperature difference. The temperature difference, that is Tc minus Td. Tc minus Td. Getting my point? So Tc minus Td. So ಮತ್ತೊಮ್ಮೆ directly proportional to ಎದಕ್ಕೆ Tc minus Td, right? So then again that same rate of flow of heat is inversely proportional to its length. Inversely proportional to its length. ಯಾಕಂದ್ರೆ length same ಇರ್ತದೆ. Length same ಇದ್ದಾಗ length ಗೆ ಜಾಸ್ತಿ ಸಂಬಂಧ ಕೊಡೋದಿಲ್ಲ. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳಿದ್ವಿ? Inversely proportional to what? Length. Inversely proportional to what? Length. So then so this is 1, this is 1, this is 2, this is what? 3. Combining these three. So then here Q by T is directly proportional to A, right? Tc minus Td. Tc minus Td कैसे बोलते हैं? Tc ಒಳಗೆ ಏನೈತಿ ಜಾಸ್ತಿ ಐತಿ, ಟಿಡಿ ಒಳಗೆ ಏನೈತಿ ಕಮ್ಮಿ ಐತಿ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋಗಿ ನಾವು ಮೈನಸ್ ಮಾಡ್ಬೇಕ್ರಿ. ಅಂದ್ರೆ ಇಲ್ಲಿ ಮೊದಲು ಇದ್ದಿದ್ದನ್ನ ನಾವು ಮೈನಸ್ ಮಾಡಿದಾಗ ಸಿಗ್ತೈತಿ, ರೈಟ್? Divided by what? Divided by what? Getting my point. So now see here, this Q by T, the rate of flow of heat, and I am totally Q by T is taken as H. I am totally H ಅಂತ ತಗೋತೀನಿ. Heat so just heat ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ತೀನಿ. ಏನು ಮೆನ್ಷನ್ ಮಾಡ್ತೀನಿ heat. So sometimes ಕೆಲವು ರೂಪದಾಗ ಏನು ತಗೊಂಡಾರೆ ಬರೀ Q ಅಷ್ಟೇ ತಗೊಂಡಾರೆ, ಬರೀ ಏನು ತಗೊಂಡಾರೆ Q. So ಅವರು ಆಮೇಲೆ ಏನು ಮಾಡೋದಿಲ್ಲ, ಇದನ್ನ modify ಮಾಡ್ಕೊಳ್ಳೋದಿಲ್ಲ, ಅಷ್ಟೇ ಬಿಟ್ಬಿಡ್ತಾರೆ Q ಅಂತ ಅಷ್ಟೇ ಬಿಟ್ಬಿಡ್ತಾರೆ. ನಾನು ರೇಟ್ ಆಫ್ ಫ್ಲೋ ಅಂತ ತಗೊಂಡಿರುವಾಗ Q by T ಅಂತ ತಗೋತೀನಿ, is equal to ಏನು ತಗೋತಿದ್ರೆ H ಅಂತ ತಗೋತೀನಿ, ಗೊತ್ತಿರಲಿ. So here Q by T is H. Getting my point? So then is equal to, I am going to remove this one, that it becomes K A Tc minus Td divided by L. Divided by L. So then here this constant K is called thermal conductivity. What? Thermal conductivity. ನಾವೇನಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ thermal conductivity ಅಂತ ಕರಿತೀವಿ. ಏನಂತ ಕರಿತೀನಿ? Thermal conductivity, right? So here where K is called thermal conductivity, it is called constant, and thermal conductivity. So where K ಅನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? thermal conductivity ಅಂತ ಕರಿತೀವಿ, right? So here if we are once again we are going to define the needs. What happens here? This heat, this rate of flow of heat is defined as the unit cross section area and temperature difference and to the inversely proportional to what? The cross section, the length of the material or the length of that rod. ಇದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? So thermal conductivity ಅಂತ ಹೇಳ್ತೀವಿ. ಏನಂತ ಹೇಳ್ತೀವಿ? thermal conductivity. ಗೊತ್ತಿರಲಿ, right? thermal conductivity. So here see once again H is equal to Ka Tc minus Td divided by L. K ಅಂದ್ರೆ ಏನೈತಿ? ಥರ್ಮಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಐತಿ, ಅದು ಏನಾಗುತ್ತೆ? ಜೌಲ್ ಆಗುತ್ತೆ. ಇದು ಅಂದ್ರೆ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಇದು ಅಂದ್ರೆ ಇದು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಮೀಟರ್ ಡಿವೈಡೆಡ್ ಬೈ ಮೀಟರ್ ಲೆಂತ್. ಇದೊಂದು ಮೀಟರ್ ಏನಾಗುತ್ತೆ? ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಜೌಲ್ಸ್. ಸೊ ಥರ್ಮಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಹೇಳಬೇಕು, ಥರ್ಮಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ನೋಡ್ರಿ ಏನಾಗ್ತೈತಿ ಅಂತಂದ್ರೆ, ಸೊ ಹಿಯರ್ H is equal to right? K is equal to I ತರ್ತಕ್ಕಂಥದ್ದು ಇದು ಏನೈತಿ? Q by T ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಏನಂತ ತಿಳ್ಕೊಳ್ಳಿ? Q by T K ಅಲ್ಲೇ ಬೇರೆ. ಸೊ Q by T ಲೈಟ್ ಅಂದಾಗ A ಕೆಳಗೆ ಬರ್ತೈತಿ, ರೈಟ್? Tc minus Td ಲೆಂತ್ ಏನ್ ಬರ್ತೈತಿ? ಮ್ಯಾಗ್ ಬರ್ತೈತಿ. ಸೊ ಇಲ್ಲಿ ಏನು ಬರ್ತೈತಿ? K ಒಂದು ಬರ್ತೈತಿ. ಸೊ ದೆನ್ once again can I write K is equal to LQ Tc minus Td A into T, right? So then here ಏನಾಗುತ್ತೆ? ಸೊ Q ಅಂದ್ರೆ ಜೌಲ್ ರೀ, ಟೆಂಪರೇಚರ್ ರೀ, ಮ್ಯಾಗ್ ಬರ್ತೈತಿ ಪರ್, ಇದು ಒಂದು L ಕ್ಯಾನ್ಸಲ್ ಆಗಿರ್ತೈತಿ ಇದ್ರೊಳಗೆ. ಸೊ ಅಂದ್ರೆ per meter per second joules per second per meter per Kelvin. ಅದು ನೀವು ಇದನ್ನ ಸೆಲ್ಸಿಯಸ್ ಅನ್ನೋದು ಏನು ಅನ್ಬೋದ್ರಿ ಕೆಲ್ವಿನ್ ಅನ್ಬೋದು. ಸೆಲ್ಸಿಯಸ್ ಅನ್ನೋದು ಏನು ಅನ್ಬೋದು ಕೆಲ್ವಿನ್. So this is the SI unit of thermal conductivity. SI unit of what? SI unit of thermal conductivity. SI unit of what? Thermal conductivity. Right. So ಯಾವಾಗಲೂ ಯಾವುದೇ ಒಂದು ರಾಡ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡಾಗ ಒಂದು ಕಡೆ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚು ಇನ್ನೊಂದು ಕಡೆ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಇದ್ದಾಗ ಸೊ ಅದರ ರೇಟ್ ಆಫ್ ಫ್ಲೋ ಆಫ್ ಹೀಟ್ ಎದು ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರ್ತದೆ ಅಂದ್ರೆ ಏರಿಯಾಗೆ ರೈಟ್ ರೀ. ಸೊ ದೆನ್ ದ ಟೆಂಪರೇಚರ್ ಡಿಫರೆನ್ಸಿಗೆ and inversely proportional to what? The length. And inversely proportional to what? The length. So then the constant is coming, that constant is called thermal conductivity. Right.